Today we are switching from arithmetic sequences and we're going into arithmetic series. So really all that happens to go from a sequence to a series just means you're adding up all your terms. A series is just very simply the sum of your terms of your sequence. So sometimes it's looking at all of the terms of the sequence, sometimes it's just looking at a few of the terms of the sequence, but what it's doing is it's just purely adding them together. So our definition here, this just represents a sequence where you got your first term, second term, third term, so on and so forth. So that represents the elements of a sequence. Then the series, S sub n, so that's the notation we use for it, that represents the sum of them. So here is our formula for the sum of an arithmetic series. Again, this is on your reference sheet. So we just need to know how to use it. We don't have to memorize it. So let's take a look at our first example. Given the arithmetic sequence defined by a sub 1 equals negative 2 and a sub n equals the previous term plus 5, then which of the following is the value of s sub 5? So s sub 5, they want us to find the sum of the first 5 terms of that sequence. So that means my n is a 5, so if I'm looking at my formula up here, I'm going to put 5 in for n. So that gives me 5 over 2 right there. Our first term is a negative 2, because they told us that. And then we have to add it to the a sub n term. So for this example, we have to add it to the 5th term, because we're trying to find the sum of the first 5 numbers. So because this is recursive, I got to figure out what my 5th term is. So if my first one is negative 2, add 5, what's my second? Plus 5, plus 5, plus 5, 18. So our 5th term is 18. So you have to know your first term and the last term that you're looking at. And now add them together, multiply it by 5 halves. What do we get? What is our sum? So again, just to reiterate, the sums associated with an arithmetic sequence is called our arithmetic series. Series just means we're adding them. And it has interesting properties, many applications and values that can be predicted with what is commonly known as rainbow addition. So we're going to go through that. And we're going to actually go through and figure out how they came up with that arithmetic series formula. So consider the arithmetic series defined by the first term is 3. Keep adding 2 to get you to your next term. So that creates my sequence right here of 3, 5, 7, 9, 11, 13, 15, 17. That's my sequence that I get. The series, based on the first 8 terms of the sequence, is shown below. Terms have been paired off as shown. So what they did is we grouped the first and the last one, then the next 2, and then the next 2, and then the next 2. That's what they refer to as the rainbow addition, because it kind of makes a little picture of a rainbow there. So if I were to add both ends of all 4 of those rainbows, what is our sum? 20. Each pair has a sum of 20. So why does it make sense that this sum is consistent? What's happening between the terms? Yeah. The amount of increase is consistent. So it's always going up by the same amount. So because of that, those pairs are always going to give you the same sum. So now how many pairs are there? 4. So using our answers from part A and C, we should be able to quickly figure out our sum. We have 4 pairs of numbers, each pair adding up to 20. So what is our sum? 80. So the sum of that series right there, of the first 8 terms, is going to be 80. And so that's how they came up with the formula. They noticed that pattern. We started off with 8 terms, but when we combined them together, it ended up giving us 4 pairs. So that's where we got the n over 2 from. How many terms? Pair them off. That's how many pairs we have. So then it was the first term plus the last term. 3 plus 17 gives us 20. All those pairs added up to 20. So all you have to really use are the first one and the last one. So that's where they got that formula from. That's how they figured out the arithmetic series formula, is the number of pairs times the sum of one of the pairs. Let's look at some examples. Which of the following is the sum of the first 100 natural numbers? Show the process that leads to your choice. So up top here, I'm just going to write my formula quickly so I don't have to keep flipping back and forth from the front. So we're trying to find the sum of the first 100 natural numbers. So our n is going to be a 100. So S sub 100. So then that would also give us in front of the parentheses 100 divided by 2. Okay, thinking of our natural numbers, what is our first natural number? 1. 100th natural number would be 100. So 1 plus 100 in there first plus the last. So then go ahead, add, and then multiply. What do we get for the sum of the first 100? 50/50. So exercise 4, find the sum of each arithmetic series described or shown below. So got a few different kind of situations we're going to run into here. So A, the sum of the 16 terms given by, and then they've got our series written out for us. So we're going to figure out the sum. How many terms do we have again? 16, so that's going to go in for our n. So it's S sub 16, and then 16 over 2. What is the first term? -10. Last term, 50. So go ahead, do your order of operation. Adding, dividing, multiplying. What do we get? 320. B, the first term is -8. The common difference is 6, and there are 20 terms. So as we start to fill in our formula, we have 20 terms, so it's going to be S sub 20, and then 20 divided by 2 starts it off. We know our first term is -8. Do we know our 20th term, though? No. We need to figure that out. So that gets connected to our other arithmetic formula that we've been using. A sub 20 equals the first plus the common difference times n minus 1. So plus 6 times 20 minus 1. So sometimes we still have to refer back to that one to find any missing pieces of information. Here we're missing our last term. So 6 times 19 plus -8 gives us what for our 20th term? 106. So now that we know that, we can add that to our first term, and now we can figure out our sum. What do we get? 980. So C, the last term is a sub 12 equals -29, and the common difference is -3. So we have 12 terms because they told us that our last term is a sub 12, so that's telling us we have 12 terms here. Do we know our first term? No. So we got to figure that out, again, using our other arithmetic formula. We know our nth term. We're trying to figure out our first one, so we're looking for a sub 1 this time. And that shouldn't be a 6. I don't know why I was thinking 6. That should be a 3. Common difference there is negative 3. So what does our first term end up being? 4. So first plus your last in your sum formula there. So 4 plus negative 29. What do we end up getting? Maybe 150? Yeah. Okay. So in our last one here, the sum of 5 plus 8 plus 11 plus 77. We know our first term. We know our last term. What's the one thing we don't know? How many terms we actually have. So again, we're going to have to figure that out first. So my nth term equals my first term plus, what's our common difference? What are we adding each time? We got to figure out what n is. What does n end up being? So 25 divided by 2 times 5 plus 77 to actually get the sum. What does our sum end up being? 1,025. So let's look at example number 5 here. We have Kirk has set up a college savings account for his son Maxwell. If Kirk deposits $100 per month in the account, increasing the amount he deposits by $10 per month, then how much will be in the account after 10 years? So he's saying first month he puts in $100, second month he puts in 110, then he puts in 120. So each month he's putting $10 more than what he had put in before. So we're trying to figure out the sum. They want to know how much is going to be in the account after 10 years. So we're trying to add up every single deposit he's made for those 10 years. Since it's dealing with an each month basis, how many months in 10 years? 120. So we're doing a sum of 120 deposits that he's made. So we start off with 120 divided by 2 for our formula. First month he deposits 100. How much does he deposit in month 120? We don't know yet. So we'll go back to the other arithmetic formula. Again, we got to find the 120th term. What's our common difference? 10, because he's putting $10 more a month. So 100 plus 10 times 119. How much does he deposit in month 120? 1,290. So add that to your 100, multiply it by 60, because 120 divided by 2 is 60. And how much money does he have at the end of 10 years? 83,400. So with the price of college these days, that's like what, a year and a half? All right, geometric series. Very similar to our arithmetic series. It's just it goes along with your geometric sequences. You're just adding up those geometric sequences. So our formula changes a little bit. This is the formula that you will be given on your reference sheet. So this is the one you're going to see. The second one here, all that they did is they distributed your a sub 1. So that's how we got a sub 1 minus a sub 1 times r to the n. You don't have to. As I said, this is the one that you're going to be seeing, so this is the one to get used to. So the nice thing, though, if you look at the different pieces of the formula, do we need to know the last term this time? No, we just need to know the first term, we need to know what the common ratio is, and we need to know how many terms we're looking at. That's how we figure out our geometric ones. So exercise 1, given a geometric series, defined by the recursive formula a sub 1 equals 3, a sub n equals the previous times 2. Which of the following is the value of s sub 5? So we're going to figure out the sum of the first 5 terms of this geometric sequence. So again, following along with my formula up here, I got to start with my a sub 1, which is a 3. And then it's 1 minus r. So looking at our recursive formula, what's our r here? 2, because that's what they're multiplying by. And that 2 is going to be to the 5th power, because we're trying to figure out the sum of the first 5. And then over 1 minus 2, because it's 1 minus r. And go ahead and plug that into your calculator. Let's see what we get for our sum of those first 5 terms. What do we get? 93. So the sum of a finite number of geometric sequence terms, so for example 5, they'll tell you how many you're looking for. It's a little less obvious than that for the arithmetic series. Arithmetic was pretty easy because they made the pairs, added them up, and you had to figure out how many pairs you had. So it's possible. So what we're going to do, the second exercise, is we're going to figure out how they came up with that formula. You won't have to be able to do that again later. We're just going to go through where it came from. So this was our explicit formula for a geometric sequence that we've used in the past, a sub 1 times r to the n minus 1. If I were trying to write out my series, though, I would start with my first term, and then I would do my first term times the common ratio to get my second term, times the ratio again, which is why it's r squared there, and keep multiplying by that ratio until we get to our end here. So that's how we write out a geometric sequence. That's what it looks like. And it's really kind of confusing sometimes, but we can do it. So now they want us to figure out r times s sub n. This right here is s sub n. That's how we write out our geometric series equation. That's what they're referring to as s sub n. So we have to do r times that. all I did was copy down the stuff from above. I didn't change anything yet. So if I start distributing my r, that gives me a sub 1 times r. When I multiply it times that second one, what do we do with those exponents on our r's? We would add them, so that becomes a sub 1 times r squared. Times that next one, we get a sub 1 times r cubed. Plus dot, dot, dot. So when I add my exponents on that next one, I got an n minus 2 plus 1. So what does that give us? It would give us n minus 1. So you got n minus 2 plus the 1 from the r out front would give you n minus 1. When I multiply it times that last one, we would just get r to the n. So all I've done is taken the sequence, or the series, how it's written, and multiplied everything by r. So now, they want us to take s sub n, which again is all that stuff up there, and they want us to subtract r times s sub n, which is the stuff that we just got over here. So I'm going to start with s sub n. All I've done again is copy that up there, down here. That's my s sub n. Then we're going to subtract from it the answer we just got from part A. So s sub n minus r times s sub n. Now, keep in mind we are subtracting. So we have an a sub 1 times r here, and I'm going to subtract an a sub 1 times r. So what happens to those? They cancel. So then my a sub 1 r squares are going to cancel. A sub 1 times r cubed. That's up here in the dot, dot, dot. We just didn't keep writing it. So that will cancel with the one that's in the dot, dot, dot. Then a sub 1 times r to the n minus 2. That's in this one's dot, dot, dot. It's there. And then r to the n minus 1, those would also cancel. So up top, we're left with a sub 1 minus a sub 1 times r to the n. Okay, so there, I just summarized what we had in part B. S sub n minus r times s sub n gave us that stuff. So they want us to write both sides of the equation from part B in their factored form. So we have a GCF right here of what? S sub n. So if I factor that out, that gives me 1 minus r. What's our GCF on the right side? A sub 1. So I take that out, that gives me 1 minus r to the n. So that's our factor form. Part D, to finish this off, to get our equation that we have up above, we would divide by the 1 minus r. And that's where the formula ends up coming from. So looking on the back, which of the following represents the sum of a geometric series with 8 terms whose first term is 3 and whose common ratio is 4? I'm going to rewrite my formula so again we don't have to keep flipping. S sub n equals a sub 1 times 1 minus r to the n all over 1 minus r. So for number 3, again, how many terms are we looking at? 8. Our first term is 3. Common ratio is 4. So 3 times 1 minus 4 to the 8th divided by 1 minus 4. Plug it in, plug it in. What do we get? 65,535. Okay, number 4, find the value of the geometric series shown below. Show the calculations that lead to your final answer. Okay, so we know our first term. Our first term is 6. What's our ratio? What are you multiplying by each time? 2. What's the one thing we don't know? N. We don't know how many terms that we have here. So using that 768 is my nth term. I'm going back to our other geometric formula that we've used. First term a sub 1 times your ratio to the n minus 1 power. So divide by 6. 768 divided by 6, what do we get? 128. Then we got 2 options here. We can do logs or 128. We can rewrite that as 2 to a power. What is that power? To the 7th. And now who remembers the rule when you have the same base? 7 equals n minus 1. So that means our n is an 8. Remember, that's our change of base formula. So now we can find our sum. Six times 1 minus 2 to the 8th, all over 1 minus 2. And what do we get? 1,530. All right, let's take a look at the next one. We got Maria places $500 at the beginning of each year into an account that earns 5% interest compounded annually. So at the beginning of year 1, she puts in $500, and that earns 5% interest every year. Then at the beginning of year 2, she puts in another $500. At the beginning of year 3, she puts in another $500. So each year she's putting in $500. That's earning 5% interest. Maria would like to determine how much money is in her account after she made her $500 deposit at the end of 10 years. Okay, so at the end of 10 years, she's earning her interest, and then she makes one more deposit. So there's plus and 500 again. So how many deposits does she actually make? 11, because she makes one each year, and then at the end of 10 years, she makes one more. You want to know how much is after her $500 deposit at the end of year 10? So at the beginning of each year, she's putting in 500, so there's 10 of them, and then there's one more at the very end of year 10. So she makes 11 deposits total. So part A, determine a formula for the amount A of t that a given $500 has grown to t years after it was placed into the account. So this is our same geometric formula we've been dealing with. Instead of a sub n, though, they told us to use A of t. What's our first amount? Puts in 500. It earns 5% interest. So what would that look like? 1.05. And that's going to be to the t power. So now this next question is kind of obvious. At the end of 10 years, which will be worth more? $500 invested in the first year or the fourth year? Explain by showing how much each is worth at the beginning of the 11th year. I mean, let's think about it. If you deposit $500 in year 1, is that going to earn more interest than depositing $500 in year 4? Yeah, pretty obvious what the answer is going to be, but they told us we have to explain by showing how much is going to be in there. So, 500 in year 1. So I deposit $500 in year 1, and at the end of each year, it's earning interest. So how many times does that earn interest? Because we're looking at the beginning of the 11th year. So did I earn interest yet? No. So how many times did I earn interest? 10 times. So how much money does that $500 deposit make? $814.45. Okay. So our 500 in year 4. How many times does that one earn interest? You would think it's 6. It'd be 7, because at the end of year 4, and then 5, 6, 7, 8, 9, 10. It actually earns interest 7 times. Because it's put in at the beginning of year 4, so it earns the interest at the end of that year. So what do we get? 103.55. So as we probably all predicted, the $500 put in year 1 clearly earned more money. So based on part B, write a geometric sum representing the amount of money in Maria's account after 10 years. So, still using A of t, just because they told us earlier to use A of t, so I'm keeping the notation the same. This is her final deposit. Because remember, at the very end of year 10, she makes one more $500 deposit. So that's that final one. At the beginning of year 10, she makes a deposit that earns the 5% interest once. The deposit she puts in at the beginning of year 9 earns interest how many times? Twice. because it earns interest at the end of year 9, and then it earned it again at the end of year 10. So then at year 8, how many times does that one earn interest? 3 times, because it'd be at the end of year 8, end of year 9, end of year 10. Dot, dot, dot. It would end with the deposit made in the very first year, which would earn interest 10 times. So there's 11 terms total, because you've got all of the years earning interest, which there's 10 of them, plus her very last deposit that she makes at the end. So last part, they want us to figure out how much money is actually in that account. So instead of like doing all the calculations and adding them all together, we can use our geometric series formula. So where A sub 1, her very first deposit was $500. So 1 minus the rate, 1 minus 0.05, and again, it happens 11 times, 11 deposits, divided by 1 minus 1.05. So how much money does she have? $7,103.39. Pretty good savings. All right, so our last one on this page. We got a person places 1 penny in a piggy bank on the first day of the month, 2 pennies on the second day, 4 pennies on the third day, and so on and so forth. Will this person be a millionaire at the end of the 31st day of the month? Show the calculations that lead to your answer. So again, what we're dealing with is they put 1 penny in there, so they have 1 cent. And then they put 2 pennies in there. And then they put 4 pennies in there. And then they would put 8 pennies in there. Dot, 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 until they get to the end of the month, until the day 31, whatever it is that they add. So what's our R here? 2, because they're doubling it. Keep multiplying it by 2. So our sum, 31, because there's 31 days, they told us. A sub 1, 0.01. As we said, our R is at 2, so it's 1 minus 2 to the 31st. All over 1 minus 2. So what do we get? How much money do they have at the end of the month? Hopefully you got this. $21,474,836.47. So, will this person be a millionaire? Yes, they most certainly would. Process is going to be the same, it's just the numbers are a little bit different. So find the sum of the first 6 term of the series 2x, and then 3x minus 1, 4x minus 2 in terms of x. So first we have to figure out what kind of series do we have. Is it arithmetic or is it geometric? Arithmetic. It'd be geometric if we had like x squared, x cubed, x to the 4th, but they're not multiplying here, they're just adding. So what are they adding to get from one term to the next? X minus 1. So our common difference here is x minus 1. So since we know it's arithmetic, our formula to find the sum again, is this one. S sub n equals n divided by 2 times first term plus last term. So we have to figure out what is our last term. So again, using our other arithmetic formula to figure out what our last term is here. Our first term is 2x. Common difference we just figured out was x minus 1. And it's going to be times 5 because that would be n minus 1. N is a 6 because we're looking for the first 6 terms, so 6 minus 1 is 5. Distribute, combine our like terms. And we should end up with a 7x minus 5. That's our 6th term. So I'm plugging it into our series formula. 6 divided by 2, 2x plus 7x minus 5 for our first term plus our 6th term. Which this is a 3. That would be 9x minus 5. 27x minus 15. That's what our sum would be. So then our last one for today. In March, the Floyd family starts saving for a vacation at the end of August. They need $1,375. The family starts with $125, and each month they deposit 20% more than the previous month. So will they save enough? So let's first figure out how many things are we adding. If they start saving at the beginning of March until the end of August, how many months is that? 6. So now before I can do the next part, is this arithmetic or geometric? Geometric, good, because it's got the 20% in there. So geometric tells us it's the first term, 1 minus r to the n. R would be 1.2 because they're depositing 20% more. That's 1.2. So starting off at $125 a month, increasing it by 20%, will they save enough for their vacation? We'll have 1241.24, so is that enough? No. So since it's not enough, we got to figure out how much do they need to start saving in the first month so that they have as much money as they're going to need. So we know that it needs to add up to be $1,375. So that's going to go in for our S. We're trying to figure out a sub 1. So that's going to stay as a sub 1. Everything else is the same as the above. 1 minus 1.2 to the 6th divided by 1 minus 1.2. If I put this over 1, cross multiply. When I cross multiply, I got negative 275 equals a sub 1 times 1 minus 1.2 to the 6th. So what do I have to do with this stuff to get a sub 1 by itself? No. Divide. which yes, you could figure out what that decimal is and then just divide by the decimal. So how much do they save up in the first month? You need to start with at least $138.47. If they start with more, it'll work, but they need at